Okay, we're ready to jump in. Let's get going. Excited to have with us Darwin Peterson, Tools, Processes, and Governance Manufacturing Engineer at Spirit Aerosystems, who will highlight the development process and status of multiple projects using the knowledge-aware approach coupled with automation. Yes, Darren? Or Darwin, sorry. The floor is yours.
All right, great. Thank you. Welcome everyone this morning. It's a pleasure to be with you and share some of the things that we've been doing at Spirit Aerosystems to enable manufacturing excellence using knowledge aware and automation. For those of you who saw my presentation last year, this contains some project updates and a rationale for the how and why of knowledge aware and automation. Spirit Aerosystems is comprised of commercial, defense and space, and aftermarket, and is a diversified design and manufacturing champion. We have a global footprint of 10 locations and over 16,000 commercial employees. We focus on 7 distinctive capabilities that define innovation and agenda for future developments. Knowledge aware and automation are considered aspects of several of these areas of focus. And interestingly, as I look to update the corporate overview slides, I found that one of the projects we're going to talk about today about torque values made it into the corporate overview. So that was interesting. So the major project we've been working on for several years, and some of you have heard previous presentations. The context for our knowledge management and data preparation task was to create a generative process planning application or applications from CAD assemblies. They needed to provide many different outputs and forms and support both humans and machines. This is a floor beam assembly line. It's one of the most variable parts of the aircraft. There are a lot of configuration changes to support customer options. So the tools and the systems that we developed would need to have significant ongoing use. We couldn't just do a one-off activity to create the content for the line. In aircraft in general, relatively low rates and high variability in complex products make justification for distinct automation a difficult challenge. There are over 300 distinct configurations for these assemblies that we needed to cover. Here's a quick sampling of some of the kinds of part types that are being installed on the basic beam. Some have electrical bonding, some sealing, some post-assembly sealing, etc. So the approach to tackle this challenge first was to get the engineering in a format and content that we needed, which was very challenging. Still working on it. Some of this engineering is relatively new. Some of it is very dated. So there's a lot of inherent variation in the content and the format. Our PLM and ERP databases are not really conducive to supporting the kind of content that we needed to create as well. So we recognized rapidly we needed to do something in addition to that, and we're utilizing Neo4j graph database. It's intensive product and process content being created. It's an exponential increase in new formalized objects and relationships, hundreds of new global parameters. If you went to a major PLM vendor, for example, and you said, how fast can you give me 300-400 new objects and get structured in your database, you're going to likely get a blank stare and a big check and a long wait. So we also, same group, our knowledge-based engineering group, created generative process planning applications, and AROS is our knowledge backend for all of this functionality. So a few words to say about this. I had this last year as well, but to explain some context for what kind of knowledge we're talking about here. I'm primarily referring to knowledge-based systems or explicit and heuristic knowledge representation. This is a lengthy conversation, could be a long presentation all its own. There's been a lot of interest in artificial intelligence in recent years, primarily computational and natural language. Explicit or heuristic was very popular in the early 90s, but sadly fell out of vogue in a lot of areas. I believe there's a broad false perception that it's been replaced by computational or natural language. From my personal experience, having been in this space essentially my entire career, the value of explicit knowledge is really impossible to overstate. It is, in many cases, part of the foundation necessary to support the other types, but a little more on that later. The foundation of the AROS tool set is explicit knowledge and provides the tools to facilitate the growth of the knowledge as well as its effective reuse. So back to our floor beam assembly line. That brief overview is really about the context in which our task lived. So explicit knowledge representation was to support the many tasks involved in this generation of a process plan and content to run this line. Complexity of context, you heard context reference to and emphasized, I think, more than once yesterday. Everybody who's been in this space understands the importance of it. The more complex and involved the context, the more challenging the knowledge representation becomes. This specific project is, of course, manufacturing processes, but it's really true in any domain, I believe. So, what has this journey been like on this major project? Well, we started off with creating, things that were more explicitly and readily known, like you see in the lower left, the KPAC. And it didn't take that long before that became much more complex sets, like the rest of them. And one thing, if you're starting out new with this, I would say some people get a bit intimidated by it. Don't expect that you're going to have everything complete or fully accurate when you start. You'll learn as you go. That's okay. Um, Sets are extremely useful, and in the KPAC competition, I'll come back to this idea as an enabler um, of a large range of content and complexity in the same original contextual call from your application. So we do utilize that extensively. Then it didn't take too long for that kind of growing content to become confusing and overwhelming for even me, the author. And I realized I needed a lot, uh, a lot more content to help me even keep straight this higher level organization and complex knowledge that was being created. I needed relationships for sets that became problematic. So I needed to plan and document a higher level of knowledge organization. That led to creating a top level map. And the vertical swim lanes, in this case, represent the logical phases progressive from left to right of content that was needed through the authoring process. So the little blue bars represent sets and conceptually or closely relate to the content that they produce. I also quickly recognized the need for a next set idea to help guide and communicate to the application where contextually to go next for additional information, and that's represented by the red lines. So a quick example of some different contexts for the same logical content we ran into had to do with determining fasteners. Engineering in our business typically do not call out complete explicit fasteners, particularly for rivets. You get a base number, a diameter, or diameter code. Our automated manufacturing stations functional differences as well as differences in standard parts necessitated different length calculation rules in different stations, all of which still met process specifications. So explicit fasteners had to be calculated in process planning context because we only have a discrete set of fasteners set up in particular stations. So, but the same basic fastener determination process, we could substitute different KPACs for rules for length calculations. And we anticipated we would need that. Time proved that we did, and we have already utilized it repeatedly. So another big challenge, I've showed this previous years, we now have another approach that we're going to take to accomplish this in value tables, but not this way. But presently, this is the way we do it. Value tables weren't really designed for this. It's difficult to manage and becomes unfeasible as your process gets too big or too many processes. But process planning by definition is a series of process assignments. You have grouping, you have sequencing. Processes can have processes, which gets very interesting, and rules can exist at each of those points or steps that need to be integrated. So for the lower level content, we created a related parameter to instruct the application where additional content could be found by going to other sets that is needed contextually. We have multiple other projects like this one in work. This one with some skin panel assemblies is in final design review. The initial project and its foundational approach for data and knowledge management and utilization is pretty much the same throughout. As you would expect, though, there's unique issues for each product and process areas because context can be very different. This project is going to incorporate a hybrid authoring approach. We'll automate as much as we can, but have a controlled input for ME to make some decisions where the cost to try to fully automate it is just not realistic. And the torque project referred to at the beginning, this one has generated a tremendous amount of attention and interest and enthusiasm in the company. In the value of knowledge management and incorporation into production. Last year, I referenced other similar kinds of projects we were interested in doing. We haven't had time yet to begin them, like heat treat and temper verification and many others. We built the AROS content and an application for the ME master data to support this to facilitate the MEs in their task. We reviewed nearly 60 specification tables relative to torque. That resulted in more than 15 different variations of required sets of inputs to get torque values. And to have the MEs do this reliably and efficiently, not a very good scenario. So we use AROS to support both the ME upfront process and the execution. And in the upfront process, the MEs and using that application get information from AROS through the application, not only what they need to put in the master data, but it also pre-tests what would come back from AROS for torque values to verify that everything exists and is working. Those values then allow us to keep the content in AROS up to date from specification changes without having to update the master data. So we're in the midst of revising over 30,000+ operations, probably going to be closer to 40,000 by the time we're done with first pass of scope. And we're probably a little over halfway through those changes today. That allows us also then to do better and further verification about torque values applied to the requirements. So a couple of ideas, considerations for doing such execution process integrations. Consider what are the boundaries between your work instructions and training. Some industries, maybe work instructions aren't that regulated, or maybe your training is very specific or not. What kind of regulatory requirements do you have to meet? How complex and extensive are the variables or process parameters? What kind of risks do you have to look them up, and what does that cost you? And of course, the terrifying one, what's the cost of failure in your case? So the opportunities in this area we think are very extensive depending on your particular process requirements. So let's talk about the why for a few minutes. I think there's a tremendous amount of overlooked opportunities here. In fact, some of them I don't know that I've ever even heard anybody else talk about. First, really out of the gate is first pass quality. It's really the foundation of all manufacturing excellence that enables every other improvement. But you can't do that without depth and breadth of product and process knowledge, which means you've got to effectively reuse it and you've got to keep it up to date, continually refine it. I I learned many years ago observing some other applications and things that we did and watching human interaction and response. Um, I didn't include some of the myths in here because takes too long to cover in this time frame, but I realized right away that this standardized and formalized the problem solving approach. You give any two individuals same task, mentally they are very likely to approach it differently, and many people don't take time to even stop and think about their own thinking. Right, they just kind of do it. They don't say, oh well, I decided this and that led to this. So I think there's a really overlooked educational method is inherent with the combination of these two things together. It's also really a right size enabler for your technical workforce. The idea is to have your clerical tasks reduced through the automation and replace that time spent by increasing their time learning and the depth and breadth of that product and process knowledge. You're developing subject matter experts. And that provides a real motivation for technical career path growth opportunities. I've told several people that I've interviewed trying to bring into this space and help me out and work with me. I've spent 30 years of my career trying to help produce this opportunity. It's laying here right in front of you like has never existed before. It's very, very exciting. So how? Work on developing a vision. Your enterprise vision gives you energy and direction. Identify some high potential value areas. Content creation might be complex or error prone. Knowledge, volume, and detail can be overwhelming to users. Those are opportune areas, or high volume usage. Stay away from the approach of cost justifying such activity by laying people off. It's a whole lot better model to focus that energy on using them to do more valuable tasks, improving and increasing the knowledge that you have. And make deliberate plans and actions about what you're going to do to develop these people and change their job roles over time. So, in summary of those things, get an enterprise vision, but you don't have to have the whole picture to begin. As mentioned yesterday, and will be probably repeated again today, start with an effective area, a place that you can gain some value and begin there. This is truly a right-sized enabler for a technical workforce. It continuously broadens and deepens your product and process knowledge, and that will improve your quality and reduce your costs, and it will increase your employee satisfaction, productivity, and retention. Easily overlooked in the technical conversation, but in the end, it's really people that matter most. It's people that need to be developed and put to use and valued. And these tools, I believe, appropriately used together, can facilitate a model that's a win for everybody and your enterprise. So, a couple of quick touch bases here. I showed this list last year. It has, I think, one item added from before. Some development things we think would be really helpful in this space of process planning. APIs for method K-packs could be very beneficial. Standard patterns, sequences of activities, sequence context for rules and activities. that could be much easier than how I'm trying to do it today. Logical looping and hierarchies. Array processing. Value tables are really designed for a single set of inputs. Find a row, process it, and return it. We've come across quite a number of cases where being able to send in a whole group of content and return a response back about the group could be extremely helpful and more efficient from an application and a call perspective. Um, regex, maybe some improvements in logical expressions. Being able to output a graphical visual relationship of KPAC sets like I show in my PowerPoints would be very nice. And simpler methods for graphic incorporation content. We're interested in collaborating with people that have such similar interests on such topics. And this is kind of a current snapshot about where we're at with content inside AROS at Spirit Aerosystems, getting close to 1,000 KPACs, 100 sets, only 10 active users. I'm still the primary author at this point, though we're getting close to engaging a number of others in that. And with that, we'll open up for questions.
Perfect. Well, thank you so much. You're clearly extremely knowledgeable in this subject, and we do have a couple of questions already. So I guess we will go in order. If you have more, continue typing those in the chat, please. We are using the chat versus Q&A for questions. So, yep, first one, Jeff is asking, are you saying Oros is computing the required torque based on specific contexts from production?
Correct. So what we did is structured the required inputs. And again, there were 15 different input differences depending on the spec and the table that the requirements were coming from. We staged those required inputs in the master data, which of course get copied into the operation in the order execution. And then when that order arrives on the MES side, MES calls AROS to get the current values and populates them for the mechanic.
Thanks, Darwin. Okay, next question from Paula. Do you see in the manufacturing process the ability for fault diagnostic training, such as simulation, and lead into lessons learned to prevent future potential fault conditions?
Absolutely. Though we haven't had time with our team to move in that direction, but yes. And I would say in general, um, the opportunities are so huge. It's exciting, really. You can pick almost any direction, and there are many opportunities, and I think they're all productive. Each company and context and the people that are available to begin this journey really have to decide where's the logical place for them to begin from a value perspective. How quickly can they implement a particular area and begin to gain value so that they can increase the support.
That makes sense. Okay, next question. If you could take us back to your investigation and choice to use Oros IQ, what features did you deem compelling enough to select Oros IQ, and what was important to Spirit's vision? There's kind of a lot there.
That's a great question. The honest truth is, we didn't know any other competitors, and frankly, I'll give God credit on this one, because from a project standpoint, we knew we needed something. I had had decades of experience in the knowledge representation space, but we had simply done things like make our own databases for lookup tables for things that users could represent externally. But that has lots of problems, right? You have to create and maintain that database. You don't have structures for managing user content without creating that as well. You got API call issues that you would have to create and maintain. So you were very limited. when we were working on this project before the official assignment, you know, was given to actually move forward, we learned about ROS at that time, and by somebody in the company who'd had previous experience with ROS, and they led us to conversations with several of the participants that are here today from GM and others, and who graciously gave us time and spent several hours with a number of us on the phone. And that's how we that's how we found out about and began to use ROS, and it's been an exciting thing to learn about and work with.
Yeah, that's really cool to hear. I love that divine timing or
Yep.
intervention. Yeah. So, another question, does the 10 user include production operators?
No, the production operators at this point are getting their information from MES, and that is application calls.
Okay,
Yep.
very good. So, yeah, I have a question. You've got some great feedback on this. I was just wondering about challenges. You may have addressed some of these, but what are some of the biggest challenges that you faced getting to this point in your project development?
Oh, great. A couple of things. One, trying to do too much at once, um, and having really, from an industry standpoint, COVID and Boeing 737 MAX problems, over 60% of our revenue is a 737 MAX. So we've had some major events, one on top of another. It's been a really tough phase. So we're short on internal resources, really pressing hard to accomplish a lot of things with a few resources. So a lot of the things that we'd like to do, we haven't yet accomplished, like increasing the participation in the communities of practice with review and approval from, for example, materials and process engineering or quality or other people. We've put two sets of eyes on most of the content I've created, for example, for the torque, but you expect to find errors. And on that note, I would say to others, again, other people get downright panicked sometimes about such things and say, well, what if I make a mistake? And, I just found some in the last 2 days of errors I made, and I have to go fix them. What I learned again over the years is do your best, but don't worry, because these approaches will also help facilitate pointing out errors, right? And it makes it quicker and easier to fix them, and the likelihood of repeat. So if I make an error from an input standpoint, that's one thing. But imagine thousands and thousands of people manually looking up or remembering or keeping a note about what a value is. I mean, the chance for error is infinitely less, right? So, you're going to improve quality taking that kind of approach in those cases.
Sure, absolutely. A couple of questions. Tara's wondering, how difficult was it to create the integration between Oros and your MES?
Uh, Well, the IT people on the MES side would have to answer that, but considering they pulled it off in about 6 weeks, 8 weeks, we did this entire first implementation in 3 4 months,
Hmm, good
and
to know.
and I would say the way we structured the content, if you had done it in a pure lookup tables in a database, there would have been over 3.5 million rows in the database.
Whoa.
We did it with probably less than 1,000 rows in Aros in total.
Oh my goodness. That's quite the testament. And then one more question here. What's the lag time between the MES and Oros?
Um, we have found it to be it's extremely small. I don't know the exact numbers.
Okay.
It's small. We have some improvements on the MES side we're still working on. We did get pressed to implement quickly before the end of the year, and we didn't get a chance to do as much, small scale testing as we would have liked to have done. We just did a second round implementation this last weekend, and we'll continue to work on some other things.